This is Hacker Public Radio, episode 3588 for Wednesday, the 4th of May 2022. Today's show is entitled Linux Inlaws S01E55. Get your boots on for a fresh look at init systems. It is part of the series Linux Inlaws. It is hosted by Monochromic and is about 46 minutes long. It carries an explicit flag. The summary is: Martin and Chris discuss what happens when you turn on a computer, preferably running Linux.
This is Linux Inlaws, a podcast on topics around free and open source software, any associated contraband, communism, the revolution in general, and whatever else fancies your tickle. Please note that this and other episodes may contain strong language, offensive humor, and other certainly not politically correct language. You have been warned. Our parents insisted on this disclaimer. Happy, Mum? Thus, the content is not suitable for consumption in the workplace, especially when played back on a speaker in an open-plan office or similar environments. Any minors under the age of 35, or any pets, including fluffy little killer bunnies, your trusted guide dog, unless on speed, and cute T-Rexes or other associated dinosaurs.
This is something called Linux Inlaws. Season 1, episode 670,528. On a much more serious note, this is Linux Inlaws, Season 1, episode 55.
Oh, you know the number. Well done.
Yes, we do. We do. How are things today?
Yeah. Good question. It depends whether we go into the big issue or not, but apart from that, everything is fine.
Big issue being init systems, of course, as in today's topic.
No, they're not a big issue. They're straightforward, as we know.
This is what Martin thinks.
Yes.
Then, Martin, do enlighten me about the big issue.
Big issue? Well, our friend in the East is not so friendly anymore. He's no longer a friend. In fact,
you mean China? You mean Trump?
Far from it. Well, I don't think Trump's in the West, surely.
Well, you see, it depends on your perspective. If you just go far enough east, you will meet him kind of on the other side.
Yes, very true, very true. Okay.
So what east are you exactly referring to?
Well, your east, but then stop by the sea.
By the sea?
Ocean. Not the sea, the ocean, yeah.
That makes it the Bering Strait? As in the divide between the US, Alaska and China? Or Mongolia, whatever it is. Geography is failing me. Martin, as usual, I'm lost.
Okay. Well, in case you hadn't noticed, there's been an invasion of Ukraine.
The war.
Well, it depends how you look at it, but some people don't call it a war, apparently.
Yeah. We're recording this on September 27th, 2025, apparently. The war that Martin is referring to started in February of 2022 and apparently is still going on. What nobody has sussed yet, and I'm joking.
Yes, course, you have a solution.
Yes, I do. Of course, I'm joking with the recording date. Actually, as a matter of fact, we're recording this kind of mid-April, mid-March, almost. Anyway, what nobody has really sussed is to keep the Kremlin at bay, especially the Falcons. NATO, sorry about the pronunciation. NATO has to extend a membership offer to Russia. Because at that, if they accept, and if Mr. Putin would put aside his, what's the word I'm looking for? Reservations, for want of a better expression, we would all be friends, and there's no need to attack friendly neighboring states. So, Vladimir, if you're listening, shut down the arms, get the troops out of the Ukraine. The Linux Inlaws will maybe get in touch with Brussels. And maybe we can work something out with regards to including you in NATO, and then it's all said and done. There is no point in further killings. Never mind putting innocent lives at risk. So, Vladimir, think about it. And if Brussels...
Feedback at Linux Inlaws .eu. Yeah.
Exactly. Exactly. The email address is feedback at Linux Inlaws.eu. And if Brussels finally extends that offer, just do it. Just accept it. Russia will be a better place. No more wars. And we finally can live in peace for a change. And don't worry about Donald Trump. We'll sort him out as the US goes along. But this is not the political or global crisis podcast, but rather Linux Inlaws about today's subject, which is, Martin?
Init systems, I believe.
Init systems, yes.
But before we start on that, you haven't told me how you are. So.
Well, I'm fine. I'm on my first bottle of beer.
Glad to hear it. It's a quiet night, is it?
Slowly running
Oh,
out.
nice.
Exactly. Yes. No, things are dandy here in what's the word I'm looking for? Kiev or whatever you put on. No, it's not Kiev. No. No, we're gonna edit this out. No, it's actually Frankfurt, Germany. So the Russians haven't approached yet because we still have a few bordering countries in between, so-called buffer zones.
Yes, it's quickly diminishing, but
yeah. Indeed. And as I said, Vladimir, if you're listening, just think ahead. And I don't know how many people are at risk if NATO would, God forbid, pull the nuclear option, because that would just result in Armageddon. And Vladimir, this is not something you want to do. If history is anything to go by, and history does repeat itself, just don't do it. In case Mr. Putin is listening, I do not know.
Yes.
But back to init systems.
Back to init systems, indeed. That's
yes, Martin. So what do you know about init systems?
Well, every Linux system has one.
Well, I'm tempted to say that every computer system has one.
Well, yes, that's true. Yes, fair enough. So, since we are a Linux podcast, we're talking about Linux.
Do we now? But this wouldn't be inclusive now, would it?
No, we don't.
Exactly, Martin.
Yeah. Being inclusive.
Okay. Before we go into the nitty-gritty details of System D, OpenRC, System V, and all the rest of it, maybe we should take a look at the bigger picture and see what happens actually if you turn on the power on a device normally known as a computer. Any thoughts?
Well, there's various things that happen. Right?
Care to enlighten us about the technical details?
Well, there are hardware bits and pieces that all.
Yes!
There are many bits inside your computer. I guess you didn't know.
Okay, we only have about 2 hours left for this episode. So why don't I basically give the kind of 20,000 mile overview?
Go for it.
Of what happens actually if you turn on the power.
Go for 20,000 feet next time. Yeah, 20,000 miles, but
whatever.
Very small spec otherwise.
So, its computer normally has something called a CPU in it and some storage devices, known as, in the olden days, EPROMs, PROMs, as an erasable, programmable read-only memory, and all the rest of it. Nowadays, probably part of some system on a chip configuration known as an SoC, and consisting of flash memory, for example. So essentially what happens, if you turn on power, the CPU does a reset, puts itself into the default state, and starts to execute executions normally at a predefined address. Hasn't changed within the last 50 years. I mean, going back to the mainframes, you could actually configure this address before the IPL, referring back to the IBM mainframes now, as in the initial program load.
Yeah.
Same goes for the, what's it called, Elster 88 something, 00, as in the first 88 as an Intel 88-based microcomputer. But in a nutshell, the CPU starts to read instructions from a predefined address. In the early home computers, that was just ROM, as in you put something onto the screen like a prompt, and then you let the user take care of the rest. But with the advent of things like an IBM PC and friends, this procedure became just more complicated. Going back in history about 50 years. It makes actually 40 years, as in I'm referring to an IBM PC type thing. You power up the machine, the CPU starts to read some instructions. This basically would mean a jump to something called a basic input-output system, also known as BIOS. And then that BIOS would do some initial hardware initialization, like clearing the screen, initializing controllers and all the rest of it, and then would see what devices are there in terms of, do we have a hard disk? Do we have a floppy disk? And then try to load an initial bootloader from said device. That hasn't really changed. Over time, the BIOS became replaced with something called a UEFI, as in Universal Extendable Firmware Interface, which is still essentially a BIOS, but is capable of much more complicated things like booting a trusted operating system, signed with keys and all the rest of it. So essentially, UEFI BIOS also contains parts of a PKI, of a public key infrastructure. The bottom line is that the original boot process hasn't really changed that much. Essentially, you take a look at the storage devices, you take a look at what's out there, you load a portion of that device into my memory and then transfer control to it. So in terms of Linux, more often than not these days, that means some sort of grub. Grub standing for, Martin?
Oh, good question.
GNOME,
no,
Ruby, interface or something? No, it's not.
No. Interesting.
What is it? Actually, the name escapes me too. It's GNU. Yeah. Maybe link. Yeah, maybe. Maybe the link. Maybe the details might be in the show notes.
Yeah, it's bootloader, isn't it? GNU bootloader.
Yes. Wikipedia to the rescue. The rescue. The GNU Grand Unified Bootloader, also known as grub. So the way the grub works is essentially, in MBR-based systems, as in the traditional IBM PC type system, systems would take a look at the mass storage units and would try to load either an MBR or GPT partition of the disk, and then in GPT or MBR-based systems, the BIOS would take a look at the first hard disk sector. In GPT systems, it's slightly different. Same goes for UEFI, but in that case, you're looking at a whole partition rather than a sector. Anyway, doesn't matter. The way it works is, and it hasn't really changed, you get some sort of initial bootloader into main memory, you execute that bootloader, and that bootloader then would take care of loading the kernel into main memory and then executing an init system. With grub, as in the GNU Grand Unified Bootloader, this bootloader is already capable of understanding, for example, file systems like ext3, like ext4, like FAT file systems. So it's able to understand this file system structure and at least is able to load a kernel, an init RD, like a RAM disk, and depending on the distro that is booting, also a configuration file. Armed with this, essentially, it's able to load a kernel, provide the kernel with an initial image, for want of a better word. It normally basically just contains some redundant or rather rudimentary userland, which is just there in basic terms to get the system up and running. Kernel executes that userland, the initial userland, and then at some stage the kernel pivots into the real userland, which is essentially stored on disk. For this, it needs a so-called init system. As we're talking about, or as we're sticking to the Linux case, of course there are multiple init systems out there, ranging from the original RC init system, right over to system V init, systemd, OpenRC, and the whole lot. Which nicely brings us back to the whole systemd debate.
Uh-huh.
So, Martin, the moment of truth has come. What can you tell us about Upstart?
It's a
defunct.
It's
Yes.
a replacement daemon starting. It starts the process asynchronously. It's in the
Very
mainly.
Yes, very good. But maybe we should start from a historical perspective at the very beginning. In the olden days, and we're talking about 1970, there was something called System V in it.
Indeed.
Exactly. BSD has
System V, did you say?
System V, yes, as in Unix System 5.
Mm-hmm. Mm-hmm.
Hence the name System V in it. Maybe now it's time to shed some light on run levels. Run levels essentially describe the state of a Unix-based operating system. Like you have a single user state where you do not have any daemons up and running. No services have been created yet. A single user mode normally consists of just a shell, a root shell to be precise, where the user sitting in front of a terminal has any rights that he or she needs to do system administration tasks. Much more importantly, there are no other users on that system at that given stage. In contrast to this, another run level would be multi-user. In that case, most of the daemons would have started. Typically, you would have the line printing system up and running. You would have terminal services listen on serial devices or network interfaces, accepting SSH-based connections and all the rest of it, or simple TTY process in terms of serial communication. And the other remaining tasks. In the 80s/90s, that run level system was complemented with, I think it's called GUI stage or something like this. Details maybe in the show notes, where actually on the main console you would have a windowing system up and running. In the 90s, more often than not, something like X Windows. Kiddies, this is Grandpa telling you stories, because these days this would be more like Wayland and Friends, not necessarily X Windows, because as we all know, X has almost fallen by the wayside to be replaced with Wayland stuff, because funny enough, not that many people use a network windowing system anymore these days. Anyway, so run levels had a couple of advantages, but also had disadvantages. Going back to the original system V init system design, in terms of, so for example, services tended to depend on other services, i.e. it doesn't make much sense to start the TTY processes before the networking layer was up and running. Because without a network connection, you simply cannot connect unless you talk about serial consoles. You cannot connect to a computer.
You may have to explain what a serial console is, but
a serial console, yes, it's something in the olden days.
For the hipsters amongst us,
exactly.
Well, not amongst us, but amongst our listeners.
In the olden days, you would use acoustic couplers or other modems to connect to a computer using a technology called RS-232, otherwise known as V24, as in a serial connection that would shovel the bits to the target system in a serial fashion, typically achieving lightning speeds like 300 bits per second. And yes, you're talking 80s.
Yeah.
Now, things things.
Wonder how many people
change.
know what a modem is in the that's less than 30 years.
Well, you see,
Anyway.
if you're using ADSL or some other DSL-based technology, yes, essentially you still use a modem, but you're talking
That's
about
fine,
now
yeah.
speeds up to, if you're using vectoring DSL, up to 200 megabits a second. Maybe even more, depending on your kit. So this has come a long way from 300 bits per second, give or take. But going back to the init system. So
Well,
essentially,
the good thing is back then
yes.
there weren't any cat videos, so you didn't need it, right? Less of a requirement for more.
Indeed, yes, indeed. But with this simple system V init, and especially with regards to the dependencies, things became very complex, very clunky, very quickly. Because essentially, what you had to do, you had to hard code these dependencies in your init files. With system V init, that would mean you have to define a numerical order in which the associated shell scripts, because that's essentially what system V is, V init, would be executed. Never mind timing issues. So you, depending on the service at hand, you had to fiddle around with sleep statements and all the rest of it, ensuring that a service which is depending on another service, or which was depending on another service, didn't start up before the other service was finished.
Yep.
Not great. So,
well,
quite
it's
a
very
few
short.
people.
It took a long time to be right, or well, not to be
Yes.
initialized. Let's put it that way. Yeah.
Yes, and it didn't help with the booting times, exactly. The sweet thing is basically that, in contrast to other operating systems, you do not reboot Linux systems regularly. Whereas in contrast, other operating systems have apparently to be rebooted regularly in order to avoid memory issues and stuff. I'm not naming any names, but a distinguished colleague of mine, we just had a chat about a month ago, pointed me out to the fact that his Debian-based system had an uptime of about 4 years. He seemed to be pretty chuffed with it. I wasn't. Because taking a look at Marzu, the longest uptime, and the uptime essentially is the period of time where a Linux-based system has been up and running since its last reboot. The longest uptime here in Marzu, and that's an ARM-based system running Alarm, soon to be decommissioned, by the way, because it's 32-bit, has an uptime of about 6 years. So I'm still running a kind of an ancient kernel on it. It's, I think, 3 point something, if memory serves correct. Needless to say, I do update the userland quite frequently, but at the end of the day, that machine hasn't rebooted for that amount of time. Which goes to say, of course, that Linux is a rock-solid system, especially, although even, let's put it this way, even if you're using a hipster operating system like this distribution called Arch. Anyway, but I'm digressing. So quite a few people identified the shortcomings of System V init and came up with alternative solutions. One of the more prominent ones probably was Canonical in the mid-teens, when they came up with an init system called Upstart. Details maybe in the show notes if I can dig them up. That essentially modeled dependencies and other interesting things in a very intuitive way, let's put it this way. But at that stage, a guy called Leonard Pöttering and Kai Sievers had already also taken a look at this issue and had come up with something called System D. Now, of course, details will be in the show notes again. System D, and if history is anything to go by, has taken the upper hand in terms of distro adoption and all the rest of it. Exactly. So Canonical, I think, gave up on Upstart about 6 years ago, back in 2016, 2017, something like this. Details will be in the show notes when actually Canonical switched from Upstart to something called System D, which at that stage quite a few distributions that already adopted. The ones like Arch. Fedora probably being the most prominent example.
Yeah.
Because funny that Kai and Leonard work for a company called Martin?
Red Hat, perhaps?
Indeed. This is why your Hello subscription does pay off. Very much so, yes.
If the Hello magazine would feature some open source.
Martin, you're not saying you pay for the bloody thing but never read it? Are you serious?
What do you think?
You heard it here first. Martin has a Hello subscription but doesn't read the bloody thing. That's impressive.
No.
What does your wife say to this? What does your wife
actually, I could be wrong. I could be wrong. It could be full of Leonard Puttering and Linus Torvalds and all those people. I don't know, actually, but it does seem somewhat unlikely.
Sorry.
Can't be very good for the reading figures, right?
I'm just wondering, what happens? The postal service in the US, also known as the post office, delivers said Hello magazine to your doorstep.
I didn't know they had Hello magazine in the US.
So.
Why would they deliver it from the US?
The UK postal service. I made a mistake, of course. Okay, the UK postal service delivers that to your doorstep. So it's on your doorstep. It's in your mailbox. What happens then? The wife picks it up, reads it, and then puts it onto the coffee table. The kids go through it, and then what?
I don't know. Why don't you ask someone?
Unfortunately, they are not.
We don't have it in our household. So I'll let you know if I find someone who actually reads the thing or has a subscription. Let's put it that way.
Martin, I'm sorely disappointed because if you have a Hello subscription, you should read it. Because in that case, you would know about these things like Leonard Puttering and all the rest of them, right? There you go. Anyway, but I'm digressing.
Yeah, just a bit.
Anyway, so over time, systemd has essentially evolved from a mere init system to much, 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 much more. And this is where the fun starts. So, Martin.
Define fun, yeah.
What's your perspective on systemd?
Well, it works.
Yes.
What else? Interesting. Don't tend to do a great deal with it. There's sometimes you need to add something to it, but
like timers and services and the
like certificate renewals.
Exactly. Yes, Martin. Certificate renewals, indeed. Okay, full disclosure, Peter. I wouldn't say I'm a converted follower of fashion, but let's take a look at how systemd has evolved. It started off as an init system. Over time, much, much more was added to systemd. It now does time zone controlling. It now has DNS functionality built into it.
Hang on, wait.
Yes.
What do you mean time zone controlling?
It's called Time Sync CTL.
Okay, so that's no longer an external daemon or a daemon that does that.
No, it can interface to an NTP service. It can interface to the
NTP daemon, that's the one I'm thinking.
Yes.
Yeah.
Yes.
Okay, so you don't need NTP daemon anymore. That's what you're saying.
No. Well, you do, but maybe not on that machine, unless you can get the network time protocol from a different server. But it's quite capable of controlling the time itself. There's also some rudimentary DNS resolver functionality built into it, and it also has a rudimentary container system called machined, if memory serves correct. So it has progressed quite beyond a simple init system. And some people, and what's following now, full disclosure, is my very own personal opinion, you may disagree. Please do send hate mail to feedback@linuxinlaws.eu and clearly put Martin in the subject line. This is the important bit.
Yeah, no problem.
I'm joking.
I can
But
relate
Martin,
very
of
easily.
course, exactly, but Martin has a corresponding proc mail filter on his account, so no worries. Anyway, no, I'm jokes aside. Some people take offense and are implying that this zoo of functionality, for want of a better expression,
Are these Linux purists by any chance?
Exactly, the purists amongst ourselves are that this functionality is against the original Unix philosophy.
Yeah. It's,
Now, Martin, of course, that begs the question, what is the original Unix philosophy? For the two people under the age of 50 listening to this podcast.
That's a good question. Well, I suppose if I were to think off the top of my head, I would say that every piece has its function.
Yes!
I don't know if that's what it is, but it has
that. Spot on.
Yes, that kind of feeling about it, right?
Back in the 70s, when AT&T sat down to devise something called the successor of Multics, known as Unix these days, Pike, Kerningham, Thompson, and the original Eventers came up with this philosophy of essentially a toolbox, where the operating system running on top of the kernel, especially the userland, would consist of 20,000 plus tools. I'm exaggerating, like quite a comprehensive number of little programs that would work in concert to achieve a goal. Hence this notion, for example, of pipes. Hence this notion of process substitutions found in most of the shells. Like you would combine these little tools in order to get the job done.
Yep.
And this is now, in my personal opinion, where the misconception sets in. Systemd is still that collection of tools. It's just the packaging, apparently, that many people take offense to, in terms of they perceive this init system and its corresponding functionality, because these days it's much more like just an init system, to be a threat to the overall original Unix philosophy. Like you have a collection of tools and they work in concert and tell them to achieve one thing. Systemd at the very core, and of course this is a matter of philosophy, debate, and you name it, hasn't really changed that philosophy. Because if you take a close look at Systemd, you have the init system, you have the resolver, you have MCP-like functionality and all the rest of it. But at the end of the day, okay, yes, they are packaged into more or less one code base. But at the end of the day, the separation of concern still applies. So I'm not really sure that I get the revolutionists, like the Devuans of the world, or those people who run Debian. The Devuan is a splinter group, hate mails to feedback at Linux Inlaws.eu. Devuan is essentially a Debian system without Systemd integrated. So I think, to the best of my knowledge, they still rely on Systemd in it, if I remember correctly. Of course, people don't get me wrong. This is still open source software. So, of course, you can do whatever the heck you want to do. Because the source code is available, just go for it. If you want to do some OpenC-based Debian with some strange sort of init system, by all means, just go ahead, fork the userland, get rid of Systemd, slot in your own functionality, and off you go. As usual, go ahead, Martin.
No, can't finish what you.
As usual, evolution will decide on what's viable or not.
Yeah, true. So what about Slackware? Should we
subject of an upcoming episode, bland teaser. We are looking at 2022. Before the year is over, we will have an episode on Slackware.
We will?
Yes, we will.
Okay, sorry, I can cut this.
Eric, Patrick, if you're listening, I sent you numerous emails.
I thought I hadn't replied to any of them. That's my recollection.
We're working on replacements. So, Eric, Patrick, if you want to get on the show, you want to make this quick because we have already a waiting list of Slack users building up to be on the show. I'm just saying. Indeed.
Okay, let's not talk about Slackware right now then, if he's coming on the show. Excellent.
But you had a question on this or other?
Well, it's yeah. So that's one of the few Linux distros that's still using init.
Well, Devuan would be the next.
Yeah. Well, this is already mentioned.
There might be more. OpenWRT is using something called OpenRC, if memory serves correct. Of course, OpenWRT being one of the major embedded Linux distributions for the likes of modems and so forth. And of course, the BSDs of the world, which of course not Linux, goes without saying, haven't gotten around to systemd yet. But as far as I know, FreeBSD and at least OpenBSD still use systemd in it. If I'm wrong, please send mail to feedback@linuxinlaws.eu.
What about Debian? I thought they were doing something.
No, Debian has been using systemd for the last 5 years, 6 years.
Okay.
They made that switch mid last decade, I think, if memory serves correct.
Fair enough.
They weren't the forerunners, but eventually they adopted this because everybody else was, like the RHELs, the Fedoras of the world, the Arches of the world, you name them, and you name them. Mm-hmm. I think they came after Ubuntu, but I might be wrong with regards to timing.
Mm. Okay.
So, any final thoughts on init systems?
Well, final thoughts. I mean, what about the So the reason for mentioning Slack was that, well, we can do it in the episode, but they had some, it's the main Slackware founder had some issues with systemd as well, right?
Like Patrick Folkerding.
Yes.
He's known to be a rebel, yes.
Uh-huh. So that was, but I think, as you say, most of the distros have adopted it now. So,
well, Devuan, Slackware, and the distro that shall go unnamed still stands out, but that's about it. The rest would have adopted systemd by now. And Devuan people, if you disagree with the following statement, please do get in touch with us at hatemail@linuxinlaws.eu, which is of course directly forwarded feedback at linuxinlaws.eu. No, I'm joking, but if stats are anything to go by, Devuan has yet to master the adoption curve of Debian because they're not quite there yet. So
actually, you're running ARM, aren't you?
ARM would be a CPU architecture.
Yes, as a hardware, yes.
Yes, I'm using ARM, yes.
With which OS again?
Google, if you're listening, the email address is sponsor@linuxinlaws.eu. Some of them, I reckon about half of my ARM cores do run something called Android or some sort of spin of the AOSP, like the Android open source project, and the other ones would run either Alarm as an Arch Linux on ARM or some sort of Debian spin.
Okay.
both of which, of course, come with systemd. Because Debian would be native Debian for ARM32.
Okay. Well, that's quite good to know then. So it is portable to many other, or portable, it's not hardware dependent, and which makes sense, really.
Systemd? No, systemd just requires a Linux kernel.
Yeah.
And
Indeed.
it can run a Linux kernel. It can run on any Linux kernel after 2.19 something, because, well, at least that goes for systemd versions that are about 2 to 3 years old. All it would require from a kernel are control groups and namespaces. Because essentially this is what you use, or this is what you need for some sort of rudimentary container control. And things like private temporary directory, private proc directories, and some other features that systemd exhibits, especially if you are talking about systemd services that have to run in isolated context. Because one of the features, again, in comparison to systemd in it, is that you can isolate a systemd service pretty much to the extent that it's almost comparable to container. Systemd, what brings the thing that systemd brings to the table with regards to isolation of, for example, a service, bordering on something that a container brings to the table in terms of you can isolate to the extent it has its own temporary file system, it has its own set of capabilities and all the rest of it, meaning that it's almost running in its own container, and that's exactly why you need something called control groups and namespaces. These concepts have been in the kernel since I think 2.19.32.35 or something like this. Details maybe in the show notes.
Very good.
Now, before we lose the remaining 2 listeners, I hope you're still awake. That's the important thing. Feedback.
It depends whether they're using us to get
Feedback, as usual, goes to complaints@redhat.com. I'm joking, people. Of course, the feedback goes to feedback@linuxinlaws.eu. What else is there to say? Of course, credits have to go to Hacker Public Radio for hosting us. Kenny for listening. Thank you. Guremi Himargut and Dankjewel. I think that captures the 3 languages that can speak.
Very good.
And
what about German? Do you not speak
well,
German?
Vielen Dank, Ken.
Okay.
If you can understand German, I don't know. And of course, Vladimir, do think about this proposal. And please, if you do, give the Linux Inlaws credit for this, just in case. This is the Linux Inlaws.
You come for the knowledge,
but stay for the madness.
Thank you for listening.
This podcast is licensed under the latest version of the Creative Commons license, type Attribution Share Alike. Credits for the intro music go to Blue Sea Roosters for their song Salute Margaret, to Twin Flames for their piece called The Flow, used for the segment intros, and finally to Celestial Ground for their song Sweet Justice, used by the Dark Side. You find these and other ditties licensed under CC at Jamendo, a website dedicated to liberate the music industry from choking copyright legislation and other crap concepts.
Martin.
Aha.
We have a guest called.
What's interesting is that the thing is quicker as well. The echo nonsense.
Yes, that's what I noticed. The logs will probably tell you why this is.
Yeah. Well, yes.
But
that sounds like too much effort.
Jesus Christ! One day, and Martin, really, this is the important bit. One day, we will come to you will come to the conclusion that a proper system administrator learning curve is not the worst thing that could happen. As in really deep down diving.
You don't get the point. It's not so much about the system administrator piece. It's just about having the time to sort out all this stuff.
This is otherwise known as a lame excuse. Never mind focus and priorities.
Yeah.
You get my drift. I rest my case.
Feel free. Who uses BSD?
I do on a daily basis.
I thought you used Arch.
Sweetie, what's macOS at its very core? It's a free BSD userland running on top.
NextOS or whatever it's called.
Martin, I think you still have to do some reading up on things.
Don't like Mac.
No, I mean,
rubbish. Yeah.
I do. You do too, apparently. And you do too.
Do what?
Use macOS.
I'm afraid so, yes.
Yeah, you're using FreeBSD essentially. Because that's what Darwin is. Darwin is a combination of a FreeBSD personality running on top of a heavily modified microkernel.
Okay.
Called XNU or something like this.
You have been listening to Hacker Public Radio at hackerpublicradio.org. Today's show was contributed by a HPR listener like yourself. If you ever thought of recording a podcast, then click on our contribute link to find out how easy it really is. Hosting for HPR has been kindly provided by anhonesthost.com, the Internet Archive, and rsync.net. Unless otherwise stated, today's show is released under a Creative Commons Attribution 4.0 International License.